So I'm going to be going over the notes from 6.1, which talks about dilations. So the definition of a dilation is a transformation that enlarges or reduces a figure proportionally. So we're going to take a shape and apply some transformation to it and get an image or a figure that is similar to the figure that we started with. So when we're talking about dilations, you might hear me use the words pre-image and image. Right. The pre-image is going to be that shape that we start with and we don't have any transformations applied to it yet. Once we do apply transformations to that figure, we're going to get what's called the image. And dilations use what we call a scale factor. So a scale factor is how much we're going to dilate the figure. Okay. It's denoted by the letter K. And the scale factor is just some number that we're going to multiply the x and y coordinates of the pre-image by. So we have what's called a rule, or just a way to note the transformation that's going on. So you could be given the coordinates of a pre-image. This arrow represents some transformation that we want applied to it. In this case, it's going to be that dilation. And again, after that transformation is applied to the coordinates of the pre-image, we are going to end up with the coordinates, or the ordered pairs, of the image. On the second page of these notes, it goes through an activity looking at using different scale factors. Okay. The first thing that they ask us to do is graph and connect these points. So we are graphing our pre-image here. So I'm going to graph 3, 2, 3, 4, 5, 2, and 5, 4. The next questions ask us to calculate and graph the image using different scale factors here. So the first one that we're going to want to do is when we have a scale factor of 2. When we have a scale factor of 2, that means that my K value is going to be 2. Right? And we know that when we use dilation, we're going to take those x and y coordinates and just multiply them by whatever our K value is. So in this specific example, if my K value is 2, we're going to take those x and y coordinates of our ordered pair and multiply each of those by 2. So that first value in your chart is filled out for you. That's how I got the 0.64, is by taking 3 times 2 to get 6 and 2 times 2 to get 4. So you can choose to pause the video at this point and calculate the rest of the coordinates, or you can just fill it out along with me here. So all I'm doing is applying my rule of that scale factor of 2 and multiplying the pre-image coordinates by that scale factor. Now that I have graphed, or now that I've calculated the ordered pairs of my image, I want to go ahead and graph that image as well. So we've got 6-4, 6-8, 10-4, and 10-8. And I want to go ahead and connect those points to make my image. Question number 3 asks us to complete a dilation with a scale factor of 3. Right? Using our same rule as before, right? We're going to multiply that k value by the x and y coordinates of our pre-image. Right? So we're always starting with our pre-image and moving to that dilation with a scale factor of 3. So to get my 0.96, I started with this pre-image coordinate or pre-image ordered pair of 3, 2. And I multiplied those coordinates by the scale factor of 3 to get 9, 6. I will let you fill out the rest of this chart and go ahead and graph it. Right? This is very similar to what we just did with their k value of 2. And I'm going to jump over to our last column in the chart, where my k value now is a fraction. So just as before, we're going to multiply our x and y coordinates by that 1/2 value. So this means for my first point, I'm going to have 3 times 1/2, which is 3/2, and I have 2 times 1/2, which is 1. Right. And if you need a quick refresher on multiplying out those fractions, right, we just multiply across with the numerator and the denominator. So 3 times 1 is 3, and 1 times 2 is 2. Right. I'm going to leave it as an improper fraction. If you like to write it out as 1.5, you can. If you want to keep it as a proper fraction or a mixed number, that's okay as well too. So I'm going to complete those same steps with the rest of my coordinates. Again, you can go ahead and pause the video at this time if you want to calculate them on your own and check your work, or you can follow along with me. So now that I've calculated my 4 points, I can go ahead and graph that image. Once you finish this activity, again, you'll have a blue square in there that is completely finished on this chart. The reflection questions ask you what happens to the shape after each dilation that we completed. Right? There's also an extension question that asks, what do you think would happen when we have a scale factor of 1? Right? Again, I'm going to ask that you fill those out on your own, just so you can form some general thoughts on what happens when we multiply those coordinates or those ordered pairs by each of those scale factors. And then the last portion of the notes, was just a summary of the two different dilations that we completed in the activity. So on your chart, you can fill in this first line as an enlargement. And we are going to call an enlargement a dilation where my K value or my scale factor is bigger than 1. Another point that you can add in there is that the figure or the shape is going to get bigger with that dilation. The second type of dilation that we saw was a reduction, right? And a reduction happened whenever our scale factor or our K value is in between 0 and 1. And we knew that a reduction was happening because the figure got smaller after we multiplied the scale factor and the coordinates. And then you can pause the video at this time to fill out the summary portion. It just goes through what I just talked about with enlargements and reductions and how we're going to dilate a figure numerically.